At the edge of a multi-lane arterial road, just beyond a signalized intersection, a maintenance vehicle from the Municipal Transportation Department is parked on the shoulder. Workers in reflective vests are replacing a damaged signpost. Traffic continues to move at speed, drivers glancing only briefly toward the roadside. The new sign, red, octagonal, and mounted at a regulated height, must be installed precisely according to specification. The work is not aesthetic. It is procedural. Measurements are checked, bolt, torque verified, and alignment confirmed with the roadway centerline. The goal is not merely to display a message, but to restore a standardized signal within a system that depends on uniform recognition. This scene reflects an institutional environment in which street signs function as regulated components of traffic control infrastructure. Municipal agencies, national transport ministries, and international standard-setting bodies coordinate to ensure that signs convey meaning through consistent visual forms. The effectiveness of a sign does not depend on its wording alone. Instead, its shape, color, size, and placement are standardized, so that recognition occurs rapidly, often before the text is consciously read. Modern road networks operate under the authority of public institutions responsible for safety, mobility, and liability management. As vehicle speeds increased during the early 20th century, local signage practices, once informal and highly variable, proved inadequate. Drivers traveling between jurisdictions encountered different colors, shapes, and symbols for similar instructions. A warning in one town might resemble a direction in another. Inconsistent visual cues increased reaction times and contributed to collisions, prompting transportation authorities to pursue uniform standards. In many countries, this standardization process is formalized through national manuals or codes. In the United States, for example, the Manual on Uniform Traffic Control Devices defines the shapes and colors for regulatory, warning, and informational signs. Comparable frameworks exist in Europe, under the Vienna Convention on Road Signs and Signals, and in numerous other regions through harmonized national standards. Although specific designs vary, the principle remains consistent. Visual uniformity enables predictable interpretation. Within this institutional framework, shapes and colors are not decorative choices. They are codified signals embedded in legal and procedural systems. A red octagon indicates a mandatory stop, not because of the word stop, but because regulations require that this shape and color combination represent that command. The legal enforceability of traffic rules depends on the reliability of these standardized visual cues. Shapes were standardized to function as immediate identifiers, recognizable even under low visibility or partial obstruction. The octagon used for stop signs is a prominent example. Transportation engineers selected this shape, in part because it is unique among common sign forms. Even when covered by snow or viewed from the reverse side, its silhouette remains identifiable. This allows drivers to anticipate the presence of a stop requirement before the sign face is fully visible. Other shapes serve similar pre-linguistic roles. Triangles are commonly used for yield or warning signs, with orientation providing additional meaning. Diamonds often indicate cautionary conditions such as roadwork or hazards ahead. Rectangles and squares typically convey regulatory or informational content. By assigning categories of instruction to distinct shapes, transportation systems reduce the cognitive load required for interpretation. The institutional adoption of shape standards followed research into human perception and reaction time. Studies conducted by traffic safety agencies demonstrated that drivers respond more quickly to shape-based cues than to text alone, particularly at higher speeds. As a result, shape standardization became a procedural requirement, embedded in engineering guidelines and procurement specifications. Color complements shape by establishing a hierarchy of urgency and function. Red is reserved for prohibitive or mandatory actions: stop, do not enter, wrong way, because of its high visibility and strong associative meaning. Yellow signals caution, alerting drivers to conditions that require increased attention. Green indicates permitted movement or directional guidance, while blue often denotes services or facilities. White and black combinations are used for regulatory information. These assignments are not arbitrary. They reflect decades of testing under varying lighting conditions, weather scenarios, and visual acuity ranges. Transportation authorities evaluate how colors perform at night under headlight illumination, in fog, and in peripheral vision. Standardization ensures that a driver approaching an unfamiliar roadway can rely on consistent color meanings without needing to interpret local conventions. Institutional procedures reinforce this consistency. Procurement contracts specify exact color values, using standardized color systems to ensure uniformity across manufacturers. Maintenance protocols require replacement signs to match. These specifications precisely, deviations are not permitted, as even minor variations can affect visibility and recognition. Standardization extends beyond shape and color to include placement, height, lateral offset, and retroreflectivity. Signs must be installed at regulated heights, so they fall within a driver's expected field of view. Distances from intersections are specified to allow sufficient reaction time at designated speeds. Reflective materials are mandated to ensure nighttime visibility. Through repeated exposure, drivers internalize these standardized cues. The stability of the system depends on this repetition. When a driver approaches an intersection, recognition of a red octagon triggers an immediate expectation of stopping behavior, often before the text is read. This learned response reduces decision-making time and contributes to predictable traffic flow. Institutional audits and inspections maintain this stability. Transportation departments conduct periodic reviews to identify non-compliant signage, faded colors, or improper placement. The goal is not merely aesthetic uniformity, but functional reliability. A sign that deviates from standards risks misinterpretation, undermining the predictability upon which the entire traffic system depends. While national standards govern local implementation, international agreements have sought to harmonize signage to accommodate cross-border travel. The Vienna Convention on Road Signs and Signals, adopted by many countries, establishes common principles for shapes, colors, and symbols. This harmonization allows drivers to interpret signs in unfamiliar countries with minimal confusion. Local adaptation remains necessary for linguistic and cultural contexts, but core visual standards are preserved. Symbols often replace text to overcome language barriers, further emphasizing the role of standardized visual design. The institutional commitment to harmonization reflects the recognition that road systems function as interconnected networks rather than isolated jurisdictions. The legal enforceability of traffic regulations relies on standardized signage. Courts often evaluate whether a sign met prescribed standards when adjudicating traffic violations. If a sign was improperly placed, obscured, or non-compliant in color or shape, enforcement actions may be invalidated. This legal dependence reinforces institutional adherence to uniform standards. Transportation agencies therefore treat signage as regulated infrastructure, rather than optional communication. Documentation accompanies installation and maintenance, ensuring traceability and compliance. The reliability of the system depends on the assumption that every sign conforms to established specifications. Over time, the repeated application of standardized shapes and colors produced a stable visual language. This stability did not emerge spontaneously. It resulted from institutional coordination, empirical research, legal codification, and continuous maintenance. Each sign installed according to specification reinforces the system's predictability. Drivers rarely consider this institutional framework. Recognition occurs automatically, supported by learned associations. Formed through repeated exposure, the system's success is measured by its invisibility. Instructions are followed without conscious effort, and traffic flows with minimal ambiguity. Today's transportation networks are more complex than those of a century ago, yet the foundational standards for signage remain largely unchanged. Advances in vehicle technology, including driver assistance systems and machine vision, rely on the same standardized shapes and colors to interpret roadway information. Automated systems are trained to recognize these visual cues, extending the relevance of established standards into digital and autonomous contexts. Municipal maintenance crews continue to replace damaged signs. According to precise specifications, ensuring continuity across decades of infrastructure evolution. International harmonization efforts persist. Accommodating increased global mobility, legal frameworks continue to depend on compliance with established standards. The consistent shapes and colors of street signs endure because they function within an institutional system that prioritizes predictability, safety, and interoperability. Through standardization and repeated application, these visual forms have become stable. Components of traffic control recognized, instantly, enforced procedurally, and maintained as essential infrastructure within modern road networks.